Hello, everyone. Welcome to another episode of the Sovereign Frontier podcast. Joining us today is Sean. Sean is the founder of Polytube Labs, where he leads research and development focused on blockchain interoperability, privacy, and scalability. Before founding Polytube Labs, he worked as a core developer at Parity Technologies, contributing to major projects such as Parity Ethereum, Substrate, and Polkadot. After leaving Parity, Sean joined Composable Finance, where he successfully led efforts to bridge Polkadot to Cosmos using the IBC framework. He also enjoys shitposting. Sean, welcome to the Sovereign Frontier podcast. Could you tell us a bit about your background, how you got into the Web3 space?
For sure. I think it was early 2016 for me. I was a very fresh college dropout working for a software company in Lagos, Nigeria. They build enterprise software. They had clients like MTN and Nestle and the like. Um, and my coworkers, they were much older than me, of course. These were married men, but I was like what, probably like 19, 20. Then I was the youngest at the office, and I heard them discussing something called Bitcoin, and I thought it was an interesting name. Bits, like that's a computer related something, but a coin, is that like some sort of digital currency? What is this? And I remember, asking them about it, and they were like, "Oh no, you should definitely buy some Bitcoin. You should definitely buy some Bitcoin." I was like, "Okay, what does it do? What does that mean? What do I do with it once I buy it?" They're like, "Oh, just you just buy it and you sell it after." And I'm like, "Okay, this sounds to me like," and we've seen this before, right? They're called MLM schemes, like the Mavrodi Ponzi. You buy some stuff and then you sell it on later on. I wasn't interested, of course, in this. I don't think that like real wealth can be built through like Ponzi schemes. Well, barefaced Ponzi schemes add no utility in it, essentially. So it was, I think, the next year, 2017, where Bitcoin crosses 1,000K, right, $1,000. My coworkers had told me about this earlier, and I was like, okay, fine, I need to look into what this is. And I think when they told me about it, it was much cheaper, anyways. So I spent some time, at nights researching Bitcoin, researching like what exactly is a blockchain, cryptography and everything. I mean, I already had some, cryptography understanding because I'm a very curious person. I like to read, especially in terms of science and technology. I like to be very well read across multiple topics, and so learning fundamentally that Bitcoin is built on this new architecture for decentralized services is, I would say, in general, is the word here. A light bulb actually just went off in my head, which was that okay, beyond just currency, I think, which there's a huge market for. There's also opportunities for blockchains to revolutionize governance. So things like voting, where I think Nigeria has seen the worst of election fraud, and continues to happen every day. A system that could, number one, allow people to vote from home where they're not like at the mercy of thugs and everything, but still authenticates their right to vote using cryptography, and is recorded on this public ledger that is immutable and unhackable and auditable. These things were, in my view, like the most important contribution that could ever be built onto a blockchain technology, and would have the most impact on, I think, the quality of life for every single person on the planet. And once I understood these things, I knew from then on I just wanted to work on blockchain technology. I wanted to work on making it more scalable, making it more accessible, making it more cheaper, making it more interoperable. And yeah, that's kind of how I got started in crypto. I started, I mean, everything's open source, right? Like that's one of my favorite things about crypto is that like everything's open source. It's not like some closed source, big tech project, whatever. I started, at least back in those days, started thinking about building an on-chain governance platform. The goal there was just to make a toy application, show everyone and see, what people thought about this. But I quickly realized that like it's very, very difficult to build application that scale even back then. And that's kind of when I knew, okay, maybe applications were not the should not be the current focus. Maybe we should be, like I said, building more scalable infrastructure at the base layer. And so I, through my open source contributions, because I, when building out the small toy project, I had made a few open source contributions to a few open source projects. It would turn out that one of these projects was actually by the Parity Ethereum team or the Parity Tech team, and they were one of the core developers of the Ethereum network and the Ethereum project. Um, the founder of Ethereum is actually also the co-founder of Ethereum itself, Gavin Wood.
Yeah.
So I remember I was on the subreddit for Ethereum. Usually I'm on there, sharing stuff, reading latest news in the space. And I discovered that this parity team is actually hiring, right? So I decided to apply because they were looking for people who would come to contribute to Ethereum, the base layer project itself, and do research and development. I thought this was an opportunity, so I don't have to do open source unpaid work anymore. Someone could basically pay me to do open source work, and I applied, and it turns out that like I had already contributed to some of their repos, and that's just kind of how I got in. So I was working for Parity from Lagos, Nigeria at the time. That was in 2018, and yeah, it's been a journey ever since.
Wow. I think this might be like my first conversation with like someone who used their developer route, right, or the building route, like code route directly into like Web3. And that's quite an interesting story that you have there, and contributing already to some of the repo, and basically getting employed, based off of your proof of work is very Web3ish.
Yes, it is. Yes, it is. That's why I
Yeah,
love the space.
yeah, yeah. By the way, congratulations on your recent raise.
Oh, thank you.
Yeah. Okay, so for for those who are probably new to cross chain technology, could you briefly explain in very simple terms what Hyperbridge is and what problem it solves?
Right. So it's a bit tricky to describe because there's also already existing bridge solutions that are like on the market today. I think we just mentioned a few of them earlier: Wormhole, Laser, and the like. These are, I think, the ones that have, in quotes, raised the most amount of money, right? Raised the most amount of capital. Um, I think the problem of cross chain simply has always been that, in order to verify that some transaction is actually coming from a blockchain that you care about. So maybe a good example here is you are on Ethereum and maybe you want to get off Ethereum. It's too expensive. You want to jump onto like BNB chain or something. Um, you make a transaction on Ethereum, and for some reason you should get the equivalent amount of that transaction on a BNB chain, right? So how does BNB chain verify that this transaction happened on Ethereum, right? It can't. Blockchains are not connected to the internet. And what I mean by that is like the environment, the virtual machine that lives on these blockchains is isolated from the internet, right? So the problem is one of verification, and typically what teams in the space do is that they introduce themselves as this verification mechanism. They say, "Oh no, I have verified this. Don't worry, trust me, and I will give you the funds on the other side." Now, this is all well and good, but those of us who are in the Web3 space, because of permissionlessness and decentralization, know that this essentially forms a vulnerability, an attack vector. And this has been exploited like multiple times. We've seen this with a recent multi-chain hack, which is a very funny story. Essentially, the developer of the multi-chain bridge got arrested, and the police forced him to withdraw all the money on the bridge. Simple, and this was that easy because he essentially had access to do this. He had the authorization to do this. It's the case that when you use a bridge that is verified by a single person, you're essentially giving them your money. It's
Mhm.
kind of like FTX.
Yeah.
You give them your money and you hope that they give them to you on the other side. And this is unfortunately still the case with existing bridges like Wormhole and Layer Zero. And this sort of architecture has been compromised before. It's not just multi-chain. There's also been Ronin network. There's also been I forget the name now, but it was also one of one of the highest profile hacks, Axie Infinity, I
Yeah.
think. Yeah.
Um,
And simply these people, the servers where they kept the keys that does this authorization was compromised, and hackers made away with over $1 billion in assets,
yeah,
right?
that's the running bridge, 600 mil. The running
Yes,
bridge.
600 mil.
Yeah,
There
crazy.
was also, I think, Poly Network as well, which is around 600 mil. And the list goes on. Honestly, it's insane, and I think I enjoin our listeners to definitely look into how much has been lost to cross-chain bridge hacks.
So
And like I said, the problem
so just a
is
quick one.
verification.
Yeah, like so just a quick one. Um, the just to answer the question, if you look at the for now, DeFi Llama tries to track the total value hacked, and currently they have over 8 billion um, in terms of hacks. Like they have 8.7 billion, and out of this 8.7 billion, 2.86 billion has been lost to bridges. Crazy.
That's about right. Yeah. So all of this loss can be traced to the fact that like the verification process is requires intermediaries. It requires trusted, specifically intermediaries. And Hyperbridge is a sort of rejection of this architecture, and it's one that embraces actually um, decentralization. So no trusted intermediaries, but instead we have verification, true verification. So back to how BNB chain would verify your transaction in Ethereum. So the truth of the matter is that much like how user accounts sign transactions that should be sent to the blockchain itself signs its own blocks, and it signs all of the transactions that it collects from everyone. And if you had a way to verify the blockchain's own signatures, because quite literally the blockchain does produce its own signatures, then you could trust that some transaction has indeed happened, right? But this verification process is very expensive, especially on EVM chains. It costs a lot of gas, and it would not be very scalable to do this directly on BNB chain. So Hyperbridge is a blockchain itself, you know, um, decentralized, that has its own economic security, that does this verification on behalf of other blockchains. And this is really not a truly new idea. I mean, as early as 2017, with the Cosmos and the Polkadot ecosystems, we saw this renaissance of this app chain paradigm where blockchains would be application specific, right? They would no longer be these generalized machines that can host any kind of application. They would pick a single struggle and they would do it very well, right? So, this was, in my view, a prophecy of what was to come. Maybe it wasn't, the crypto space wasn't ready for that, for this sort of paradigm then. But I would definitely say that this is now quickly starting to become the case. We're now sort of inundated with like L2s everywhere. I don't think there's a market for the 500th L2. I think that we are now going to enter a paradigm of application specific blockchains, and Hyperbridge is really going to be one of the first examples of a blockchain that does one specific thing and does it for the benefit of the entire crypto space. So just to quickly recap, um, Hyperbridge is a bridge, but it's also not really a bridge. It's more of a computer. It's more of a coprocessor. It's just that the fact that it's able to perform this verification, all the computing that's required for this verification, this then facilitates cross-chain interactions, right? So you can do, developers can send arbitrary data from one chain to the other. They can send maybe NFT metadata. They can send token metadata. They can also request information about what is happening on other blockchains. They can say, okay, what's this? What's the balance of this account on that chain? I want to know it on another chain so that I can do some information with it, right? And I think that this essentially is how we create new application paradigms on Web3. Because, like, if you think about it, there's not a lot of applications that can exist on a single L1, like the different kinds of applications that can exist on a single L1. We've explored all of them. It's DeFi, so DEX is lending, all sorts of stuff. It's maybe speculative stuff like NFTs. And really, those are all in the top applications. And the problem, really, the problem there is that, like, okay, what data do these applications have access to in the first place, right? Like, what data is on chain? It's just tokens. That's all that's on chain. It's tokens. And so by increasing the amount of data that applications have access to, we can then create new applications that can operate over this data. So I give examples here. I think very recently we saw the San Francisco um, government put all of its title deeds for cars on chain, but they did that on Avalanche, right? So if you were trying to maybe build an application that requires this data, you would have to go build an Avalanche, which is not really, I would say, it's not a good way to scale, right? Because you have users who don't use Avalanche, but they still want to use this data, right? So you know, interoperability unlocks these kinds of applications where blockchains become application specific, where they host specific kinds of data or they host specific kinds of applications, but other applications can still access this functionality and can still access this data.
That's interesting. So basically, you have these giant databases, and then you need a sort of application or infrastructure that will connect all of these giant databases and be feeding the information to like relevant applications that are building on these databases. Like you say, blockchains are basically giant databases and all of that. So I'm trying to like visualize this thing where you have Hyperbridge that is in the middle of these databases, some of which act like virtual machines that you can build applications on top, and it has the ability to pull data from different databases that do not interpolate, right? But then Hyperbridge comes in and then is able to offer you the data from that, and you can use it in your application, or you can innovate using that data in this like separate environment.
Exactly.
Okay, cool. All right. So you mentioned I think coprocessor model. We'll get to that real quick, but before that, we did mention the the hacking and the security problems when it comes to cross chain. So you did mention bridges like Wormhole, Ronin, and a lot that have been hacked before, and so there is a huge security risk when it comes to interoperability solutions out there. How does Hyperbridge ensure secure cross-chain communication, or how do you do it? How do you make sure that applications that are going to be building and one way or the other using Hyperbridge or leveraging Hyperbridge stays secure?
Fundamentally, I'd say the answer to this is a proof-based architecture. This verify, don't trust. Applications that leverage Hyperbridge don't trust Hyperbridge fundamentally at all, or don't need to trust Hyperbridge. And the reason for this is because, first off, Hyperbridge is an open blockchain, right? Something that I think not a lot of people understand yet is that blockchains, the reason why they're so great is that they are verifiable computers. Every node in the network is re-executing every single thing that the network claims to do so that they can check it for themselves. And so if you say, well, I'm going to perform some computation that's going to check that transactions are indeed signed by some specific blockchains, and then everyone on the network checks it, this is fundamentally more secure than someone else just telling you, oh, I checked it and it's just me that checked it. Does that make sense?
Trust me, bro.
Exactly, right. So this is how Hyperbridge is not only secure, but it's also secure because it's decentralized, right? That's why blockchains are secure and I mean, blockchains are also like secure because they're decentralized, right? It's not the fact that you don't trust the bank. It's that the bank is centralized, and when they do things like change your balance or take your money away from you, um, no one else can stop them from doing this. But in a decentralized system, well, um, everybody has a share or has a role to play in controlling the network, and so no one single person can decide what the network should do. And so this is exactly how Hyperbridge is able to then bridge multiple blockchains just by simply being this higher order blockchain that does all the verification processes, um, and then tells other blockchains, okay, I've done all this verification. And of course, you can check it because it's open. You can go to my transaction explorer and see that I've done this, and you can then use this information on your application.
Awesome. That's a better way of putting or presenting it than I was trying to visualize it for the normal for the normal person. So yeah, definitely. Okay, so let's get a bit technical. Going through your website and your document, you make mention of cryptography a lot, and so basically the whole one of the things that is unique or that Hyperbridge is doing uniquely is trying to leverage zero knowledge technology into what you are building. So is there a way that you can let normal people like us understand how cryptographic proofs are being used in Hyperbridge, and how that makes Hyperbridge unique from other solutions out there, interoperability solutions out there?
For sure. So maybe a bit of a refresher on cryptography. It's just this branch of computer science that deals with authentication and encryption in a very, very broad sense, right? Authentication meaning, well, if for instance, if I sign into a website, right, the website will issue me some piece of data that every time I come back to the website and I show this piece of data, the website knows it's me, right? Whether you call them tokens, whether you call them like API keys, whatever the case may be, right? So this is the fundament. This is basically called authentication. So we use cryptography primarily for authentication. Um, we use signatures, digital signature schemes. So much like what blockchains themselves already use to authorize transactions to be executed, um, the same thing as well is used by the blockchains to sign its own blocks, and we need to verify the signatures. We need to authenticate that okay, the blockchain that we're trying to bridge has said that some specific transactions are final, right? So they produce these signatures whenever transactions reach finality. And so we need to verify these, and this is a cryptographic operation. We also need to verify what's inside of the blockchain's database itself, right? It's application states. Okay, some application may be an ERC20 token. What is the balance of an account? Or what is the message that this application wants to send to a different chain? Because they don't really put that message anywhere. They put it in the blockchain state itself, and so we just have to look at the blockchain states and then pass that message across. So these are some of the ways in which we use cryptography. What I've just described so far are what we call consensus proofs and state proofs. And we also have these libraries that allow us to verify the consensus proofs of any kind of blockchain. So we have one for Ethereum. So this is why we're able to support Ethereum and its rollups. We have one for BNB chain. We're working on one for Polygon. It is not yet out, but will be soon. Of course, all of our code is open source. And we just want to continue to grow the number of chains we support by continuing to work on these cryptography libraries for verifying the network, the consensus proofs of all these different networks. And we also use zero knowledge proofs in specific cases. We're not a purely zero knowledge or ZK bridge, as they like to say on crypto Twitter. I don't think that there can exist any kind of ZK bridge or pure ZK bridge, fundamentally because ZK is very expensive to prove, and that introduces not only costs but latency. So your crushing transactions will take longer to deliver. Um, and so we use ZK, like I said, in this very application specific context. So we, for instance, we use ZK to verify Ethereum's consensus proof. So specifically only Ethereum. Other blockchains, they don't really have very large validator sets like BNB chain probably has like 21 validators. So you don't need ZK to verify this. You can just verify this on chain. But Ethereum that has over a million validators, this actually presents a problem to verify this on chain. So we then have to employ the use of ZK proofs. We also use ZK for Polkadot's own consensus. So the way that Hyperbridge works is that, well, it's a hyperbridge, right? It's bridged to all chains. It collects the finality proofs of all chains and collects the messages from all chains, and then it itself is sending its own finality proofs and sending its own messages to all the different chains. And it's built on top of Polkadot, so that means that we are actually producing proofs of Polkadot's consensus. Now, to make this cheaply verifiable on all chains, we also have to employ ZK here as well. So, Hyperbridge is this combination of a cryptoeconomic blockchain as well as zero knowledge proofs to facilitate cheap and fast bridging.
So, what specific role does like Polkadot plays in Hyperbridge infrastructure? I think you you leverage Polkadot a lot, right? Like the architecture of Polkadot, parachains, a lot. So, can you like what role does it play?
So Hyperbridge is basically a Polkadot rollup. I guess is the word that more people are familiar
Oh,
with.
okay, okay.
And what does a rollup gain from the base layer? It gains consensus, it gains economic security. It also gains computational throughput because essentially, well, I guess in the case of Polkadot, anyways, Polkadot is a special kind of base layer where it actually validates its own rollup. So Polkadot rollups don't have that 7-day finality; they have actually instant finality. And this is on, and also Polkadot is able to do this concurrently for multiple rollups, right? So this means Hyperbridge itself can be a multi-core blockchain or a multi-core application of Polkadot. I mean, and the reason for this is, well, if Hyperbridge is a blockchain that is supposed to then process cross-chain transactions from multiple blockchains, it's inevitable that there will be a bottleneck, right? Hyperbridge will become a bottleneck. And the reason we alleviate, the way we alleviate this issue is simply by horizontal scaling, right? This is how applications have scaled in the real world, right? If people are DDoSing your server, you just spin up a new server and you add a load balancer, and now you have two servers serving the load, right? So same thing has to happen on blockchains. And Polkadot really is leading the pack with this kind of architecture where, well, if your single blockchain or rollup becomes, flooded with transactions, you can actually spin up a second one side by side and split up the work across these two blockchains. And so this is one of the many features that we leverage from Polkadot.
Wow. So Polkadot layer twos are called parachains, correct?
Yes.
So Hyperbridge basically is a parachain that is solving interoperability challenges within the bigger Web3 space.
Yes.
Wow. Okay. Cool. Cool. All right. So, let's talk a little bit about how developers can leverage Hyperbridge to create multi-chain decentralized applications. So, if you were to speak to developers, what kind of applications are you looking for them to build on Hyperbridge, or how can Hyperbridge help them realize their multi-chain decentralized application dreams?
I think one of the most interesting applications right now on Hyperbridge would be token bridges. So different kinds. There's different kinds of architectures for token bridges, right? There's like mint and burn. There's like intents, which is essentially someone giving you the asset on the other side and then coming back to withdraw the asset that you escrowed. Um, there's also lock and mint bridges. So there's different kinds of token bridges, and I think, of course, financial applications are one of the biggest application spaces for blockchains. So we're interested in working with developers who want to build, token bridges, real-world asset issuers who want to be able to issue assets and have these assets be available multi-chain through Hyperbridge. Um, these are at the very top of mind for us. But then there's all kinds of stuff that you can do. You can build multi-chain dexes. You can build cross-chain lending. We have partners that are all building all different kinds of things. We have partners that are building liquid staking applications, cross-chain liquid staking applications, allowing people who hold crypto assets to be able to have instant liquidity for their staked assets, no matter what chain that they're on. We have partners that are using Hyperbridge to send verified ZK proofs to different blockchains wherever they're needed, because you can imagine these proofs are verified on one chain, but then they cannot be accessible on multiple chains, right? We have already partners with a few real world asset issuers, as well as we're looking into more esoteric stuff like cross chain privacy. So honestly, the application space is really, really huge. It's like I said, it's more than okay, just building on a single L1, because now you have access to more users, more geographies, and I think more liquidity.
So are you saying whatever you envision you can build leveraging Hyperbridge?
Definitely, definitely.
Okay. So with the ability to build cross-chain apps or dApps comes the issue of liquidity fragmentation. Have you by chance, or have your team at Hyperbridge by chance come up with a solution to liquidity fragmentation, or something that is built within or that is built into Hyperbridge?
We do have some token standard and our own token bridge, and we see liquidity fragmentation as a consequence of slow finality, as a fundamental first reason. Secondly, as a consequence of different blockchain architectures, right? Different blockchain environments in general. And well, it's a consequence. It's this is inevitable, right? That's because Web3 is an open space. Anyone can come and do whatever they want. They don't necessarily have to follow standards or whatever. Um, but if we are able to build a an interoperability standard, right? If Hyperbridge is able to become this interoperability standard, then I think liquidity fragmentation will be a thing of the past, because you can essentially either you lock the asset on one side and you mint the asset on the other side, or you just completely burn the asset on one side and you mint it on the other side, and you're not paying slippage or liquidity fees, or losing a percentage of your money to liquidity providers, or to AMMs who are essentially now middlemen, right? Like you burn exactly 100 ETH, you get exactly 100 ETH on the other side. And I think this is going to have to be the future of blockchains if we want to be, I guess, the future of finance, like people will say. The finance has to tend towards efficiency, not more and more middlemen in the way.
Makes sense. Makes sense. All right. So, if from the conversation so far, let me summarize this. So, Hyperbridge is developing cross-chain interoperability using a hub model. Okay, I saw this definition somewhere. Using a hub model to scale verifiable interoperability across multiple blockchains. It integrates zero-knowledge technology and mechanistics protocols to offer secure cross-chain messaging and storage query solutions. All right, two things I want to break down here is the hub model and mechanistic protocols, right? So using a hub model, can you explain to us what this hub model is?
Well, the hub model was originally invented by Polkadot, which I worked on. Polkadot's hub model is very, very opinionated in that, well, you essentially have to be a rollup to be securely interoperable with other rollups. Hyperbridge itself is a rollup of Polkadot, but then it's able to extend secure interoperability by not requiring you to be a rollup of Hyperbridge, but by just requiring you to have verifiable consensus, to have some notion of finality. As long as your blockchain has some notion of finality and we're able to verify this finality, then we can bridge you to other blockchains that also have some notion of finality, right? So this hub can really be seen as like I want to say something that enforces agreements, right? Like, uh, you know, different blockchains, they have different ways of coming to finality, and they want someone who's going to essentially enforce these finality, these finality conditions before messages can be exchanged. So the most efficient way to do this is to have a central hub to do this. If you have, sort of separate hubs, then this becomes fragmented and it doesn't really scale in terms of network effects, in terms of liquidity. So a hub model is really the best model to do this. I know there's people in the Cosmos ecosystem that reject hubs, but that's also why they're nowhere today, because there is no shared security or shared hub, which becomes that Schelling point, right? Which becomes that point where everything grows outward of or outward from. And the second thing, I guess, is the idea of mechanistic protocols. So this is why I said you can't really have purely ZK bridges, because a pure ZK bridge basically only makes cryptographic assumptions. But the problem is blockchains don't just make cryptographic assumptions; they actually make mechanistic assumptions, right? What does that mean? Example of this is in proof of stake. And in proof of stake, there is the assumption that, well, if validators are double signing, then they can get slashed. This is a mechanistic assumption. We don't simply assume that validators will always sign the correct thing. We have a protocol in place for when they try to game the system. So this is a mechanistic design approach. And so a bridge that only makes cryptographic assumptions and doesn't assume that validators can be malicious, then they're just going to be compromised all the time. And so we have a mechanistic system where we look at, okay, blockchains claim to have finalized this. We're going to wait a bit. We're going to see if there's anyone that disputes this claim, right? And if no one does, then we allow for this finality to attest to new messages that should be relayed, right? Which without, like I said, we would be vulnerable to like double signing and 51% attacks. So, this hub that also, provides these mechanistic guarantees is essentially the end game for interoperability in blockchains.
Okay. Okay. All right. So, um, what happens if during the wait period someone protests?
So quite simply, we disregard the claimed the claimed finalized block, right? Because typically, what happens is blockchains make claims about some blocks that have been finalized with the intention to then bring in new messages that were finalized by this block, that can then be sent to other chains. But if the block that they're claiming to be finalized is in fact fraudulent, then that also means that the transactions that they're trying to bring in is also fraudulent and will only cause damage on other networks. And so, if we receive a dispute for this claim, then we disregard every transaction that is finalized by that block.
Okay. I don't want to get too technical with with this, but that's a very interesting design choice that you have, and I guess that is the zero knowledge technology and the mechanistic protocols design is one of the unique ways that Hyperbridge achieves security with their like solution. So yeah. Okay, so let's okay, yeah, one more thing. One of the issues that we're having in crypto generally is UX, right? It's UX. And when you are going cross chain, it's far worse. So how are you addressing this with Hyperbridge?
I think user experience actually is a property of the blockchains that you choose to use. So this is not something that Hyperbridge, I would say, introduces any UX hurdles whatsoever. From the perspective of anyone that uses Hyperbridge or uses an application that is using Hyperbridge underneath, they will simply make a transaction on one chain and then something else will happen on another chain. It's entirely up to the applications, right, to decide what the user experience looks like. You don't have to sign a Hyperbridge transaction. You don't have to have a Hyperbridge wallet. You don't have to have the Hyperbridge token in order to use the Hyperbridge as a bridge, really, right? So, um, like I said, it's going to entirely depend on the user experience of the blockchain that you're already on. What does their wallets look like? What is their signing looks like? What does their gas policy looks like? Right. That's an entirely a problem of the chain that you've decided to use. But I can guarantee that users will never have to, for whatever reason, have the Hyperbridge token or need to use the Hyperbridge wallet or something. All of that will be handled by the application. Um, because ultimately it's the application that makes a call to Hyperbridge to send a message, right? So all of that, all the whatever fees, whatever things that need to happen, the application will handle all of that and abstract it away from the user.
All right. So, what technologies or what projects out there are being powered Hyperbridge at the moment? Could you give us a few?
Right. So we're not live yet, but we are going live this quarter. So when we've already announced a few partners who are also going live this quarter. So a few of them are like CK Verify, Gnosis Chain, um, Bifrost, which is a liquid staking protocol, and we're also working with dexes, decentralized dexes that want to bring in cross-chain liquidity like hydration. Honestly, the list goes on.
Okay. All right. So the let's come out of the technical conversation a bit and let's talk some general stuff, right? This is more personal. What is an underrated blockchain technology or innovation that you think doesn't get enough attention, in your opinion? Also, as someone who is directly working at the tech level.
I think ZK proofs are very, very overpowered. I think they will usher in a new age for blockchains, which is privacy, which I think is very critical for mass adoption. I think we that are in the blockchain space, we're just so hyped about the technology, right? We're just so excited about the possibilities that we're not actually like, okay, also considering the pitfalls, which is that now everyone can see your balances and everyone can see every transaction that you made. This is not going to scale to the masses because essentially we've created a panopticon, a system that is a surveillance or powers a surveillance state. And so we're going to definitely need privacy for all, even also companies to come on chain, right? To hold their balances on chain and to make salary payments on chain and for them to interact with other on chain companies. Um, I think also is that Polkadot is very, very underappreciated in the fact that they pioneered a lot of the stuff that is now happening today. It pioneered the roll-up architecture. It was the first blockchain with roll-ups, really. It was the first blockchain with interoperable roll-ups as well. It was also the first blockchain with fast finality, right, for its roll-ups. So I think the industry has mostly been psyoped by the Ethereum crowd because they're the loudest, but the Ethereum rollup architecture falls short. At a lot of places. They don't have fast finality, and if you want fast finality, then you have to have expensive provers for ZK. And even though you have these, they're still not interoperable because they're all run by different people, and there's no common interoperability standard. The Ethereum blockchain itself also has like 21 minutes finality as well. So it's like how exactly am I going to use this for payments if I'm going to be waiting after I paid in line at the supermarket? So you need to wait for finality, sir, before we let you leave the groceries. This doesn't really make any sense, right? So um, these are the two things that I think combined actually it can create killer applications. Polkadot plus ZK. It's not going to be Ethereum plus ZK. It's going to be Polkadot plus ZK.
Wow. That's a bold statement. Yeah, excited to see how it plays out. But I guess there's also a very interesting thing playing out, with the way the entire, technology when it comes to blockchains are evolving, right? But for example, if you take a look at where you are building Hyperbridge, which borrows or leverages Polkadot technologies, but then someone within the EVM ecosystem could build an application leveraging Hyperbridge tech, right? Someone within another ecosystem, I don't know, like maybe Avalanche or Polygon, could build an application still leveraging Hyperbridge tech stack. So I think we are getting to a point where there's a lot of innovations that are happening, and developers or builders are going to have the choice of picking which technology to build on, but then they are also connected underneath, right? So you could be within the EVM ecosystem, but different part of your technology is powered by Polkadot tech or tech that also leverages Polkadot infrastructure or technology. So yeah, I think it's a very interesting times that we are headed. Okay, what in your opinion?
For sure.
Yeah, what in your opinion is like the biggest win till date when it comes to the interoperability space, or what do you think will be the biggest win if it were to happen, or
I
if
think
yeah.
I think if Ethereum is able to have faster finality, then this would help everyone's lives immensely. Although I don't think this is going to be the case. I think actually its finality times are only going to get worse. Yeah, it's a very tricky spot because you are essentially sacrificing fast finality and user experience for decentralization in quotes. And I say in quotes because sure, you're like, okay, we want to have as many nodes on the network, but like half of them is controlled by Lido. So did we really did we really sacrifice UX for decentralization, or did we sacrifice it for centralization, right? So these are very philosophical questions I think the Ethereum community still have to um, figure out. Um, I think all of the technology that we need for interoperability are already like they already exist today. I think Polytube Labs has also been critical in pioneering some of these technologies, like our libraries that for verifying the consensus of different blockchains. They're all open source and they can be used by anyone. And in fact, they're actually being used by another like they're being used by other protocols. They're being used by teams like Succinct Labs. They're being used by teams like Union. They're being used by Axelar. So all the technology that trustless that need to exist to power trustless interoperability, in my view, already exists. It's just up to one person to assemble all of them together, like we've already done with Hyperbridge, and put them in markets.
Okay. I promise not to get technical, but then maybe one or two more questions in relation to some of the tech of Hyperbridge, then we would move away. So there is something that you call the coprocessor model. Could you highlight that and help us understand what it is about?
So the idea of a coprocessor is simply that generalized computing is great for most applications, but for some more, I guess, esoteric kinds of application, it falls short. So examples of this, very very common example would be a graphics coprocessor, right? Like you have your CPU, but you still need this GPU that can process shaders and can process graphics. But there's actually so many more coprocessors that you don't even know, right? There's the image sensor, which is able to co-process images coming from your camera. You have the gyroscope coprocessor, which actually is able to process data about the gyroscope and accelerometer of your phone. This doesn't just work on CPUs because CPUs were not designed for the kind of computation that's needed to process this data, right? So there's, like I said, tons of different kinds of coprocessors on your phone alone. And so, we've learned these lessons in traditional computing and in traditional like technology systems, and we're now having to relearn this in blockchains, right? So, a coprocessor in the context of a blockchain system is, well, essentially something that is able to augment the computational capability of a blockchain, something like Hyperbridge is doing, and is specialized primarily for this specific kind of computation. Well, in this case, proofs of interoperability, where they would have been too expensive to be done on the blockchain itself, but the blockchain can delegate this computation to Hyperbridge, and Hyperbridge performs this computation and then returns back the results, right? The verified messages that should be processed.
Oh, wow. So Hyperbridge now uses a blockchain coprocessor to validate consensus and state proofs across multiple blockchains.
Yes, this is exactly what it does.
Wow. Okay. That's definitely interesting. So all right, so back to some of the yes, some of the general questions. And again, as someone who is at the tech level trying to solve a lot of the interoperability challenges that is facing the ecosystem, what are some of the biggest drawbacks or some of the biggest challenges that you currently face or you had to face?
Yeah, I mean, I think the biggest challenge, and it's not really just me, but it's really facing the entire industry, is this like pontification of everything, right? This, um, we've strayed far away from the original designs and the original machinations of Satoshi and the early cypherpunks who were interested in divorcing money from the state. I think that we're now in this very cynical, very ponzified version of crypto where it's like, okay, what meme coin should I ape into? No one's really thinking about the fundamentals of the technology. They're buying tokens made by washed up celebrities, and it's all about money go up, right? It's all about number go up. It's no longer about, okay, this decentralized, this permissionless money platform that enables and gives everyone this level playing field. And as a result, we've seen platforms that are honestly they're just someone else's servers rise to power, like Solana and the rest, and honestly threatening to actually wreck this industry. And in fact, it's my opinion that maybe these platforms are even planted by the governments, right? Because the government doesn't like crypto. This is very clear. They've made this very clear, and crypto threatens to replace the central function of governments, which is the flow of money. And that's what they do. They control the flow of money. And the modus operandi of the government is not to outrightly destroy things, right? They co-opt it, and they corrupt it. They did this for communism, for the Soviet era. They did this for the civil rights movement. They've done this. This is how they operate, right? They infiltrate, they divert the original ideas and the original mission into something that is now perverse and is now essentially strayed far away from its original goal. And then at the last minute, where we are now sort of, we're now amnesiacs, right? We've completely forgotten what we're supposed to do here. They come in and they co-opt everything, right? Okay, it's like you guys need guidance. They start to release guidance and regulatory frameworks for blockchains. I think at that point we would have lost, right? Like, and they're already trying to do this. In fact, right, they're already releasing regulatory frameworks. For instance, chat applications. They want, and if you saw this very recently, but the government says, well, every chat application should be ready to provide them with the chat history of any user that they ask for. And this, they will have something similar for blockchains. They would say, well, any blockchain should be ready to censor specific applications that they don't like, or censor specific people that they don't like from receiving money, the same way they do for banks. And centralized blockchains that are controlled by a few people rather than a decentralized and permissionless network are going to be the first people to get this. But then they want a situation where the entire world actually is on these centralized platforms, right? And so, I find that the biggest threat to crypto is this nihilism and this cynicism around true decentralization in exchange for short-term monetary compensation, which will long-term essentially lead to digital slavery.
And I can't even begin to imagine how that might feel to someone who is trying to do the right thing, right? Like especially in trying to build the right system, and it feels like there's just a very few of those, cypherpunk punks left, and yeah, I think that would be a very difficult situation to be in. Imagine trying to build all these truly decentralized technologies, but then you have like an entire new generation of builders that come in who don't really care about all these original values, and once they can make money, they are good, and to an extent where they are more than okay to collaborate with the government, um, and yeah, just just to make it yeah, I don't I can't even imagine like how it will feel like to be a builder in such a a situation. um but
I mean,
yeah.
for me, I think it's like these people are not going to last for a long time. I think that inevitably decentralization and these values will win out. Maybe it's just in the short term they're the loudest, and I just feel bad for anyone who falls into their trap. But people who have something to lose, they're always going to stick with decentralized systems.
Yeah, and I hope I really hope that decentralization wins at the end of the day, because yeah, it's the new players that are coming into the space, right? Especially from these big banks. You now have ETFs um, that are controlled by the Black Rocks, and they we've seen how basically they being in control of the traditional financial system. We've seen how that has ended, and how that has basically been a reason why a majority or certain part of the world has been basically cut off. So I really, really hope that we decentralization wins at the end of the day. If not, then yeah, it will be sad.
I think it's going to be a long fight. I think it's not going to be an easy win. Especially like you said, with big banks coming in and essentially buying up tokens which can be used to run validator nodes in the network.
Yeah.
And ultimately, as you know, validators are actually at the pinnacle of the network. They're the ones who decide what the network even is in the first place, right? So these are philosophical questions that we will need to, like I said, answer
Yeah,
later in the future.
we used to be worried about 51% attacks, um, more in the like externally, thinking that if you have a network, like the government would directly come in and 51% attack you. But I think the new fear with regards to 51% attack is what you are saying, or is what you are talking about, is where you have all these big organizations or traditional organizations come in, start buying up these tokens gradually, right, over years, and then they get to a point where now you have all major banks owning stake in key protocols and having millions of these tokens. And we know that if you go a step above these corporations, they have people who own them, and they can coordinate. When it comes to protecting their interests, they can truly coordinate. And that is how they've been able to coordinate and have the traditional financial system running. So, yeah, it's a bit scary, but it's also a very interesting future, because yeah, it if you have these top organizations having a large stake in your protocol, and they coordinate or they're able to coordinate to attack the protocol, I feel like it will happen. I feel like it will happen, and so it's just like a matter of time.
I think it's already happening. I think it's already happening.
Yeah. All right. So talking of decentralization, I know that one of the things that Hyperbridge has is permissionless relayers. So Hyperbridge has this industry-leading architecture which allows anyone to permissionlessly relay cross-chain messages and be fully incentivized to do so, right? So, could you, if there are people out there who want to become like a relayers, what is the process? How can they become relayers to help decentralize the Hyperbridge network?
So essentially, relayers are they're how do I put this? Maybe they're more of the moving part of Hyperbridge.
Mm.
Hyperbridge, well, itself is just a blockchain, right? But then, how do messages enter Hyperbridge, and how do they arrive at their destinations? This is essentially what relayers do. You run some piece of software, and this software can run anywhere. It can run on your phone, can run on your laptop, can run on a Raspberry Pi. It's very lightweight. Luckily, we're not like the rest of the industry, and by relaying messages, you can get paid for this. Applications that want to send messages, they will say, well, I want to leave a small tip for anyone who relay my message. And if you do relay this message, then you're entitled to collecting that tip, right? But even more critically is that relayers are actually also Hyperbridge's block producers. So remember that Hyperbridge is validated by Polkadot. So we don't really have validators, right? So we don't have people that bond network tokens for security. What we have are simply people that produce blocks that can be validated by the base layer. And so if you're an active relayer, then you become eligible to become a block producer and also earn even more rewards for producing blocks for the network. And this is essentially how we maintain Hyperbridge being this very decentralized thing, right? Unlike other networks where essentially you have to bond tokens to become a block producer or to become a validator. In Hyperbridge's case, as long as you do some work for the network, you are entitled to become a block producer. And so this is essentially, like I said, how we keep Hyperbridge decentralized, because relayers are essentially permissionless. Anyone can run a relayer, and we will only select the top relayers in the past session to become block producers for the next session, right? And so this keeps the set of block producers constantly rotating. I don't think it's going to be possible to ever capture the block producing set of Hyperbridge, unlike other networks.
Okay. What are some exciting things, or what are some things that you're excited about that are coming out of Hyperbridge in a next couple of months?
I think it's for us. It's going to be mainnets for sure, wallet integrations, our partner integrations, seeing all the cool things that other people are going to build on our infrastructure. I think that's definitely what's going to keep us excited for the longest time.
Okay, so for the DJs out there, when token. Yeah, this is a message from the DJs. They said I should ask you when token, say.
We unfortunately haven't made any plans for the token at the moment, but for sure it's needed in order to have governance of the Hyperbridge protocol and to have decentralization of the block producers. I would say Q2 next year, thereabouts. I'm not making
Awesome.
any promises.
Awesome. I mean, once you say that the network will be decentralized, that's all DJs want to hear about. If the network will be decentralized, then that answers the question. All right, so just a quick one, some personal touches before we go. And I know we are in a very chaotic space, and so some of the questions I like to ask our guest, what are some hobbies or interests that you do outside Web3 that helps you keep your sanity?
I play a lot of tennis. I play a lot of tennis, and I've been enjoying it very recently.
Okay, so which of the tennis? Is it the long or the
The
table?
classic, the classic lawn tennis.
Okay.
Not any of these recent what do they call them again? With the paddles. I forget their name because it's just so weird. I don't know how who comes up with these things.
Okay. So what?
Padel or something.
Mm-hmm. But what's a fun fact about yourself that not many people know?
A fun fact about myself.
Mm-hmm.
I don't know. I would like to keep all fun facts about myself secret.
Okay. So if I say,
um,
mm-hmm,
no, I was gonna say maybe I enjoy sci-fi. I enjoy a lot of sci-fi, a lot of philosophy. I mean, this is very much obvious.
yeah, what is your most banger shit post ever?
I don't know. I would have to say it was the Gavin Wood, Anatoly post.
Oh, okay.
Yeah, apparently pissed off the entire Solana community. I posted a picture of Gavin Wood's tweets to commit ratio, And I posted Anatoly's tweets to commit ratio, and of course you can imagine Gav has way more commits and less tweets, and the opposite is true for Anatoly. And this actually went viral. I think it had like 300K views, and even Anatoly himself had to come comment and be like, "Well, he's doing founder-led marketing and whatnot," and the entire community, the entire Solana community went up in arms. But for me, I wasn't really, I didn't mean anything by it, right? Like a lot of people like to shit on Polkadot and everything and say that, well, where's Polkadot today? To me, I was just saying, well, this is what Polkadot is, right? Like the founder is still building, and he's still building for the future. He doesn't feel like his work is complete, and to me, that's kind of the best kinds of communities. I mean, same thing that Vitalik is doing, right?
Yeah, and I do also think that the Polkadot community captures the spirit of heads down building. I think more than probably any other like community out there. So like less noise, heads down, build. What is
Exactly.
Yeah? What is a take that you have in Web3 that most wouldn't agree with?
Um, I don't know. All my takes, no one agrees with them, so it's not like there's just one specific one.
Okay.
Um, I think that like ZK rollups are a terrible idea.
Ooh, yo, that's a
That's
hot
one thing.
one. That's a hot one.
Yeah, no, I understand why people don't agree with me, but my argument fundamentally is that a single person producing proofs is not very different from a bank.
Hmm.
What we want is decentralization and permissionlessness, so that no single person can be censored. But if you have one person who has all of the control and all of the power, we just reinvented a bank, and you can submit a transaction to an L2, a ZK-L2, and they can reject your transaction, and it's well within their rights to do so, especially if they're maybe based in the US.
Nah, this is a hot take. This is a hot take. In fact, it's a news. It's a headline hot take. Sean,
I mean, I don't
founder
think it's a
of
hot take at
Polytube.
all. I don't think it's a hot
Polytube.
take at all.
No, I mean, if we had time, I would have loved to to delve deeper and pick your brains on this, right? Um, Unfortunately, the time is far gone, and I guess my last two questions is: a decade from now, what do you foresee for blockchain interoperability? How will the scene or the ecosystem look like? What?
My one hope is simply that blockchains also become bridged to the real world, and this is also something that we're working on at Hyperbridge, essentially allowing smart contracts to access real world data to make like API queries. Because let's think about it, like the richness of an application truly depends on the kinds of data it has access to. Look at AI. AI really has existed since the 70s, but is only now able to provide this very rich experience because of how much data these companies have been able to scrape from the web. The same thing goes for blockchain applications. It needs access to more data. It needs access to like what's happening in the world. Can it call weather data? Can it call your bank? Can it call some specific service? Can it access how much power you're using and operate over this data? Can it make payments for you in the real world? So these are things that I think need to be solved before blockchains can actually truly have an impact on everyday people, not just crypto degens.
Okay, all right. Any final thoughts? Anything I should have asked I didn't ask? Any other thing you want to add to the conversation before we go?
I think we've already covered a lot. It's been great chatting with you, honestly, and hopefully we will continue to speak soon in the future.
Absolutely. Nah, I mean, I'm bringing you back to come talk about YZK.
For sure, for
Yeah,
sure.
but Sean, it's been a pleasure having you on the podcast. This has been very very insightful, and I think for someone who is non-technical, this has given me a lot of insight into how some of the stuff work behind the scenes or at the deeper level, and I hope that everyone out there enjoys the conversation and also gets the kind of insight that I've gotten and the kind of value that I've gotten from the conversation. So yeah, thank you very much for passing through.
Yeah, thank you for having me once again.
Awesome. So none of what we share is a financial advice. Make sure that you always do your research. Until the next one, stay safe and peace out.